Morning students, welcome to the session number 24. So in the last session we are discussing about what are the components of a nuclear power station. So in the nuclear power station we are seeing the main important component is fuel rods, control rods, coolant and moderator. Okay, later the common things are the reactor vessel and biological shieldings. So these are the different types of components. So based on the components and the working phenomena, okay, nuclear power plants are again classified into different types. So types of reactor. So in the present session we are going to the types of reactors. So what are the different types of reactors? Okay, so here the main important reactors generally we are using is the pressurized water reactor and the boiling water reactor, sodium graphite reactor, cooled air reactor, gas cooled reactor, radiation hazards and shielding. Okay, so these are the concepts here. Okay, so out of which in the present session I would like to discuss about mainly two things. One is the pressurized water reactor. So in a pressurized water reactor, what happened with the reactor on the water? So here we are using a high pressure of water. So what happens when the water pressure is increases? Okay, so generally the boiling point of water, as per our knowledge, so the boiling point of water is 100 degrees centigrade at a temperature of at a pressure of 1 atmospheric pressure. But if you rise the pressure, automatically the boiling point is increases. So if the pressure is increases, automatically what happens? The boiling point is increases. So if you are using the boiling point is very high here, okay, so that's the reason we are using water in a pressurized condition. So a very high pressure, so that's the reason the water is contained in a liquid format at a 200 temperature itself. Okay, and one more reactor we are today's class we are discussing about gas cooled reactor. So here we are using the gas, okay, helium and helium gases, and carbon dioxide gases we are using as a coolant. Okay. So what we are using as a coolant, based on the coolant we are saying that this is the gas cooled reactors and the pressurized water reactor. So here the main objective of a reactor classification is based on the coolant. So water as a coolant. So water as a coolant when it is applied. So when we are using a very high temperature itself, but having a very high pressure. So high temperature means the water temperature around 200 degrees centigrade. Generally, as per atmospheric condition, it is converted into the superheated steam. But in our case, we are using the very high pressure. So that's why at a high pressure range, so at 200 degrees centigrade of temperature, the water is still in the state of liquid format. So these are the things we would like to discuss in the present class. So see here, a pressurized water reactor. So what happened with the pressurized water reactor? In a pressurized water reactor is simply represented as a PWR. So what are the uses of a PWR? So generally a PWR is used in a sealed system to prevent the water circulating through the core from the boiler due to high pressure. So here we are circulating the water through the core, okay, and in a sealed method, okay, and the heat from this system is removed by the water. So the main objective of a coolant is to remove the heat generated inside the reactors. So reactor is a part, it continuously generates the heat energy due to the fission reactions. The chain reactions are continuously doing. At that time, it releases a lot highest amount of a heat energy. So that heat energy we need to remove continuously. It is operated by using of a coolant. That coolant is a water. So what are the materials we are using for a coolant? So for a coolant, we are using different types of materials. Especially we are using water, that is H2O, and deuterium, heavy water. So that is the TTO. So these are the generally we are using. So most of the cases in a nuclear reactor we are using moderator and the coolant as the similar materials. Okay. moderator and coolant as a similar material like water and heavy waters tutorial. Okay, and here coming to this, the heat from the system is removed by the water in pipes to steam generators. Okay, so that is the thing, working principle of a pressurized water reactor. What happens with the process? So in this process, the pressurized water reactor, natural and highly enriched fuel is used. So which type of fuel we are using here? Natural fuel we are obtained from the natural. We are using the enrichment method for increasing the energy levels. Okay, so both we can utilize. Okay, some cases if you want a normal amount of energy, at that case we can utilize a natural uranium-235. Otherwise, if you want more amount of heat energy, so at that time we are using the enriching method, man-made method. Okay, and PWR is just ordinary water under high pressure. So already we discussed, we are using as a coolant of the water, ordinary water only, but we are using at a high pressure condition. So high pressure condition is a superheated water as coolant to remove the heat generated by nuclear chain reaction from the nuclear fuel. So is it clear? The thing is, the simplest thing, the cold water, natural water we are using as a coolant, but we are using a pressurized water. So we need to generate some pressure for the water for stabilize at a condition of a liquid state. So what is the design of a PWR reactors? Okay, so the design also very important in a pressurized water reactor. So here the light water is used as a primary coolant in a PWR. Normal water we are using as a coolant for a PWR. It enters the bottom reactor core at a temperature of 275 degrees centigrade. So it's a very high temperature, superheated temperature, and it is heated as it flows upwards. So like this. Okay, so this is a reactor here. So the water is moving from the bottom side at a temperature of 275, the high pressure. Okay, flows upwards through the reactor core to a temperature about 350 degrees centigrade. So the temperature is increases due to its moving continuously from the reactor vessel. Okay, so in the reactor vessel the high temperatures are there, so that's the reason we are increasing the pressure of the water. Then only the water is not converted into the form of steam, otherwise the water is converted to the steam format. Okay, and PWR are the most common type of power producing nuclear reactor and are widely used in power stations such as ships and marine systems. So where we can apply this PWR system. So PWR is a very useful system for the power sector, such as marines and ships. Okay, submarines all over the world we are using as a PWR as a reactor as well. Because it's a very easy and we can use only increase the pressure of the water things. So what is the layout of a pressurized water reactor? See here, so this is the reactor vessels. Okay, so the entire working principle of a nuclear power station is explained by this schematic diagram. So what are the main important components of a pressurized water reactor? So in a pressurized water reactor, the main important component is the reactor. Okay, so any nuclear power plant, the important thing is reactor vessel. So this is the reactor vessel. So in this reactor vessel generally what we have? So in this reactor vessel generally we have the fuel rods. So in between the fuel rods we have a control rods. So what is the use of a control rods? So the control rods are continuously stabilize the chain reactions. Okay. The thing is the control rods are absorbing the neutrons. Otherwise the neutron is collide with another nucleus and it is split into some other particles, so the chain reaction is continuous. So that reason we are arranging the here control rods, and here we need to supply the water continuously for cooling purpose. And later we are using the primary water circuit here, and this is the pressurizer concept. So this is a very important here. So we need to utilize the very high pressure. So that's why we are using one pressurizer, pumps. So generally we are using pumps for increasing the pressure concept only. That is nothing but a pump only. So after that it passes. Okay, and it goes to conversion into the steam format by using a heat exchanger. So this is our heat exchanger concepts. Okay, or nothing but a boiler. So generally in the steam power plants, we know that the components of a steam power plant is the turbine and the boiler. So boiler is a device where the water is converted into the liquid format, so steam format. So similarly here also we have a steam and heat exchanger. So here we are sending the high pressure water, but at the same time we are giving some amount of heat energy here that is converted into the form of steam here. Okay. So the steam is flowing on the turbine. Okay. So steam have a high kinetic energy. So that kinetic energy is converted into the mechanical energy by using of a turbine. So that mechanical energy is converted into the electrical energy by using of a generator. So that is our main aim. So entire thing is related to a conversion of energy into the one form to the another form. Okay. So here the kinetic energy is converted into the mechanical energy by using of a component of turbine, and by using of a generator, the turbine mechanical energy is converted into the electrical energy. But what happened here? So some amount of steam is expanded here. So expanded steam is converted into the form of some amount of water. But we need to convert that amount of steam, some amount of steam and some amount of water totally into the liquid format. So that is happened with using of a device, condenser. Okay. So condenser is a device, it condensates the steam into the liquid format. Okay. So for that purpose, what we need to supply? So for that purpose, we need to supply the cooling water here. So here the cooling water is in. And then the point high temperature steam is converted into the water format, and the water is removed here. So what we are sending the cooling water, that water is converted into the hot format and returned back there. And here what happened? So the inside circle is there. So the flow pipe, the steam is converted into the liquid format. Again we are sending back to the secondary circuit. So here we are divided into two circuits. One is the primary circuit and the second one is the secondary circuit here. Okay. So this is about pressurized water reactor. The main important variation here, simple thing, we are using the pressurizer in the primary circuit. Okay. So what are the advantages of a primary circuit? So we have different types of nuclear reactor. So why we are using the pressurized water reactor especially? So that is very simple here. In a PWR, reactors are very stable due to their tendency to produce less power. Okay, so these are the very stable at all conditions due to low pressure, less power generation capacity. Okay, less power as temperature increases. Okay, so this makes the reactor easier to operate from a stability standard points. So this is the thing we are using PWR as the reactor for the submarines and the ships. Okay. So the main thing is produces less power as the temperature is increases. And next one is PWR reactor can operate with a core containing less fissile materials. So by using less materials, it gives a continuous power. That is also one best advantages for a PWR reactor, pressurized water reactor. So these are the very important for our final examinations, types of reactors. So please go through it and draw the diagrams very properly. Okay, so that gives a clear idea how to operate and what are the advantages here. And some more advantages are there. So as for PWR reactor, can use ordinary water as a coolant, moderator, hence less expensive and easily available. So we are using a natural water. So naturally available water, so that automatically reduces the expenses of a nuclear reactor establishment or continuous processes. And next thing is PWR turbine cycle loop is separated from the primary loop. So here we see the two loops. One is the primary loop and second one is the secondary loop. Okay, so due to the separation of thing, the water in the secondary loop is not contaminated. by radioactive materials. So here only we are directly contact with the fissile materials or reactor content. Okay, so in the secondary part we don't have a radioactive impact. So that is also a beauty of a PWR reactors. Okay, so PWR turbine cycle loop is separated from the primary loop. So the water in the secondary loop is not contaminated by radioactive materials. So these are the best advantages of a PWR reactors. And coming to the disadvantages. So here also we feel we found some disadvantages. So the most disadvantage of a reactor is the coolant water must be highly pressurized. The thing is the pressurization part only very difficult to remain a liquid at high temperatures. So why we need to do this? So the liquid in the state of liquid format only, the water in the form of liquid format only. But otherwise, if you reduce the pressure, automatically the liquid is converted to the steam format. So that is the some disadvantage of pressurized water reactor. This requires high strength piping and heavy pressure vessel, and hence increase the construction cost. So it cost increases method because high pressure means we need to establish a great pipelines and strengthen pipelines. Okay. So that automatically increases the cost of a power plant, construction cost of a power plant. And second thing is most pressurized water reactors can't be refilled while operating. Okay. So if you want to replace the water, but it takes some time for pressurizing, so that's why it's very difficult to replace the common water at a direct point while operating. This decreases the availability of the reactor. It has to go offline for comparably long period of time. Maybe it takes some weeks of time for pressurizing the concept. If you are feeding the water, so no need of shutdown of a project. But if you want to do this project, injecting the water, high pressurized water, it takes some time. So it's a second disadvantage of a pressurized water reactor. So these are the advantages and disadvantages of a pressurized water reactors. And coming to the second type of a reactor, so that is a gas cooled reactor. So in the previous case we are using the pressurized water as a coolant, but in the present class we are seeing the gas cooled reactor. So GCR uses most of the cases CO2 gas as a coolant. CO2 gas as a coolant to remove the heat from the core. So then it is piped through the steam generator where heat is removed from a gas and it can then recirculation to the reactor. So the thing is very simple. Here we are using the CO2 gas as a coolant for removing the heat from the reactor. Okay, so as usual, steam generator is used to drive the turbine and generate electricity. So the functioning is same. By using the turbine only we are generating the mechanical energy that is connected to the generator, and there we are getting the electrical energy. The entire functioning is same. The problem is the thing variation is we are using coolant as a gas, that is a carbon dioxide. Okay. And graphite is also used as a moderator here. The other type of coolant used can be air, helium and hydrogen also. So not only a carbon dioxide we can utilize as a coolant, we can utilize air. Air is a mixture of gases, or otherwise you can utilize helium or utilize hydrogen also we can utilize as a coolant. But the moderator here we are using most of the cases is a graphite contain carbon contents. Okay. So these are the content of a gas cooled reactor. So in a gas cooled reactor the thing is, so this is a reactor, the components are similar. Gas cooled reactor is there. Okay. So this is a reactor. So in a reactor we are continuously flow the water. So the thing is the same. The flow, the working fluid is steam only. How the steam is generated is very important. So in a thermal power stations we are using coal or biomass for generating the heat energy. But in case of a nuclear reactor, we are using nuclear fuel for generating the electrical heat energy. The thing is same, and the components are varies. Okay, so here we are using gas cooling system. So this is in continuously cool down the reactors because the vast amount of energy is releases. So that's why we need to remove the heat for getting the higher efficiencies and proper protection of the entire power stations. So this is also one cycle, power primary cycle, and later what we have to do, that reactor sends the water here and that water is converted into the steam format and that steam is flow on a turbine. So the thing is same, we are just replacing the high pressurized water, okay, in place of a gas. Okay, the turbine is fixed. So here the kinetic energy is there and the turbine works as a mechanical energy and here it generates the electrical energy. So the functioning is same here. Okay, so the only variation is here varying the coolant. So what type of coolant we are using? Generally, if you are using CO2, carbon dioxide, otherwise air as a coolant, or sometimes we are using hydrogen as a coolant. Okay, so the moderator here we are using a gas-cooled reactor is graphite. So that is the variation here. Otherwise, everything is common, and in a PWR, the moderator is water only. The moderator is water only. Okay. So the functioning is the same for all. So what are the advantages of a gas-cooled reactor? So the gas-cooled reactors, the processing of the fuel is simple. Okay. And no corrosion problems here. So we are using gases, so that's why there is no question of a corrosion. If you are using a water, that maybe causes to a corrosion problems. And here, the graphite remains stable under irradiation at high temperatures. So here we are using a moderator as a graphite, so it's a very stable at very high temperatures also. So that is also good advantage. We are using graphite as a moderator other than the water content. And the use of carbon dioxide as a coolant completely eliminates the possibility of explosion in the reactor. So here we are using the carbon dioxide. So carbon dioxide is a flame arrestor like that. Okay, so it doesn't use. Generally, we are using carbon dioxide for fire accident, for close the fire incidents. Okay, so the thing is very helpful when it takes place the blast and all. So it automatically controls the fire. The use of carbon dioxide coolant completely eliminates the possibility of explosion in the reactor, which always in the water powered plants. And it has some disadvantages. So what are the disadvantages of a gas-cooled reactors? In a gas-cooled reactors, okay, so the main disadvantages is power density is very low when compared to the water-cooled reactors. Okay, so due to lower heat transfer coefficient, because the gas contains a very low heat transfer rate, so whenever heat transfer rate is low, automatically the power density is reduces. So therefore, large vessel is required for this. And if helium is used as instead of CO2, the leakage of gas is a major problem, because helium is a very lightweight gas. So automatically, if the lightweight gas means always it is trying to move upwards, so it's very easy to escape from that point. Okay, so that is also some disadvantages by using of a gas-cooled reactors. If you use a carbon dioxide, it is having a atomic number of 44 high density content only. It's very less chances. Instead of helium, you can use. If helium you can use, automatically it removes leakages are very high in case of a helium usages. And the third one is more power is required for the coolant circulation. So here we are using the air. That air also we need to send it to the very high pressure levels. So that's the reason we need to utilize the pumping system. So that is very more costly when compared to the other. So more power is required for that. Fuel loading is more elaborated and costly. So here the fuel loading in a system also very elaborated. We need to do it, and the cost also very high. So these are some disadvantages of a gas-cooled reactors. Okay, and so these are the things. Now I would like to summarize this today's class. So in today's class, the main motto of the today's class is types of nuclear reactors. So what are the types of nuclear reactors? types of nuclear reactors. So here, the main thing is that we are using different types of reactors. One is PWR, pressurized water reactor, and next one is the boiling water reactor, BWR, and next one is gas cooled reactors. So everywhere we are using coolant as a water, that water is pressurized condition. Here we are using boiling water, here we are using the gas as a coolant, and sometimes we are using the homogeneous reactors. So in the next class we will see that. So in the main today's class we are going to the pressurized water reactor. So in a pressurized water reactor mainly we have two circuits, primary circuit and the secondary circuit. So what is the process of a PWR? In a PWR, pressurized water reactor, we are sending to the water in a two circuits. In the first circuit itself, the water is converted into the high pressure levels by using of a pressurizer. So here we are using the one pressurizer or pump here. So pressurizer we require very much. Okay. On the secondary reactor, it converts to the steam format, and the steam is flowing on a turbine. Automatically the turbine generates the mechanical energy and it is converted into the electrical energy. So what are the advantages of a pressurized water reactors? So the main advantages of a pressurized water reactor is So in a pressurized water reactor, the thing is the water is not contaminated because we are using the two levels, so that's why not contaminated due to the radioactive content. Okay, and here it is very useful to generate the power. Okay, it is very useful to generate the power, so that's why we are using in a submarines and the ships while increasing the temperature conditions. Similarly, it is having some disadvantages also. So what are the disadvantages here? So for increasing the pressure, we need to utilize a strong pipelines. So maybe it cost increases total amount of a project. Okay, and also it causes to the some corrosion problems. Also, maybe we can face it by using a pressurized water reactors. Okay. Similarly, in the today's class we are gone through the gas cooled reactors. So in a gas cooled reactors we are using different types of gases. So especially we are using the carbon dioxide, air, hydrogen, and helium. So different types of gases are available. We can utilize any gases as a coolant. So the most important thing is these are the coolants. Okay, and here in this project we are using the moderator as a graphite. So here the moderator also plays a vital role here. So the moderator is the graphite here. So due to the graphite we have some flexibilities are there. So the graphite is most stable at a high temperature conditions. So it's very stable at a high temperature conditions. High temperatures, stable conditions. Okay, but the thing is in a graphite conditions or any other conditions, here also two circuits are there. The function is we are using the just replacing the carbon dioxide as a coolant or gas as a coolant. The problem it has some advantages and disadvantages also. So what are the advantages here? So the advantage of a gas cooled reactor is it's a very useful to generate, and operating conditions are very simple. Operation is very simple. So there is no corrosion problems. So corrosion problems are very less. So we are using gas as a coolant, that's why corrosion problems are less. At the same time, it is having some disadvantages. So what are the disadvantages of a gas cooled reactors? So in a gas cooled reactor, the main disadvantages is if you utilize a helium as a coolant, and at that time we can face more leakage problems. Okay, so this is the biggest disadvantage of a gas-cooled reactors. Okay, so these are the things. In the next class, we will see the boiling water reactor on the homogeneous reactors. Okay, so these are the very important concepts. Please remember it very carefully. Okay, and draw the diagrams perfectly. Okay, thank you.